Okay. I think we are live. Let's go. Hold on. Okay. प्रतीक तू काही म्हणू शकतो लाईक व्हॉइस चेक.
हॅलो. नाही, नाही. आता
हा
येतं का आवाज?
हा
आता
येत
कन्फर्म.
नाईस लाऊड अँड क्लिअर.
एकच नंबर. तर मी काय म्हणत होतो, हे बघ, तुला मी मगाशी जी बुक दाखवली ना, तर ती बुक गो प्रोग्रामिंग लँग्वेजची, ती झाल्यानंतर देअर इज वन थिंग विजिबल. सांग फक्त, दिसतंय का?
येस. ये.
तर ठीक आहे. हे हे गो काटा म्हणून आहेत. तर हे कोडिंग चॅलेंजेस असतात
हा.
आणि म्हणजे प्युअरली गो मध्येच आणि एव्हरीथिंग रिलेटेड टू त्यामध्ये वेगळे वेगळे टॉपिक्स आहेत. आणि म्हणजे जसं की कॉन्करन्सी हँडलिंग झालं, परफॉर्मन्स झालं, वगैरे वगैरे. ठीक आहे. फाईल सिस्टम आणि ते जेव्हा तू इथे हे जाशील ना, तर इट इज लाईक काय करायचंय, सिनेरिओ काय, काय चॅलेंज आहे, हे एवढं सगळं करून म्हणजे टेस्ट करायचं आणि त्यानंतर हे रिसोर्सेस पण दिलेत. तर हे काय बोलतात, स्वतःहून करायचं गो काटास. तर
ओके.
लाईक जर मला गोलँग शिकायची होती खूप वेळा अगोदर, तर मी असंच एक्सप्लोर करत होतो. हो, थोड्या महिन्या 1 वर्ष झाला असेल अगोदर. तर मी असं बघितलं होतं की नाही का, की गोलँगचं तू ट्युटोरियल वाचायचं आणि किंवा त्याच्यात तू शिकायचं. गो बाय एक्झाम्पल झालं आणि गोलँगची ऑफिशियल हे काय बोलतात ते ऑफिशियल पेजवरती तिथून शिकायचं आणि देन यू मूव्ह टू दीज गोकाटास आणि त्याच्यानंतर ते सॉल्व्ह झाल्यानंतर देन यू आर लाईक at a good position to read and write the code in Golang by yourself. Like at least 75, 65, 75% तू स्वतःहून लिहू शकतो. आणि इफ यू आर इन टू गोलँग आणि तू त्याच पाथला कंटिन्यू करणार असेल तर इट इज व्हेरी गुड. कारण की गोलँग असं आहे ना की गोलँग इज क्वाईट काय बोलतात निश लँग्वेज असे तिथे त्याच्यामध्ये जास्त लोक पण नाहीये आणि त्याच्यामध्ये काय बोलतात खूप खूप चांगले इंजिनियर्स आहेत असं आहेत. तर इफ लाईक आपल्याला जर गोलँगनीच कंटिन्यू करायचं असेल तर वेल अँड गुड. कारण की युजफुल तर आहेच ही लँग्वेज, नो डाऊट. हॅलो.
ओके. फेअर. आपण मग हे करू नेक्स्ट टाइम.
चालतंय ना, काही विषय नाही.
होल्ड ऑन. रिनेम. सो आज आपण another video codec from scratch. Okay. Yeah. I think. Okay. Let me check. Okay. I think streamer was the screen visible. Okay. Nice.
ओके, अच्छा ठीक आहे. मी बघतो इकडून.
हाँ. नहीं ठीक है. So what the thing is कि आधी we need like a game plan कि because what even is a this thing, right, video encoder. ते आपल्याला आधी like हे करावं लागेल, sort of understand कि video encoder slash coder. Okay, so from what I know, video encoder काय असतं, a video encoder is basically compression but for this thing, videos. तर इथे there is विकिपीडिया आर्टिकल काढलं आणि याचं इन्स्पिरेशन सॉर्ट इथून मिळालं होतं. हे दिस वॉज लाईक द सेकंड टॉपिक ऑन द सजेशन लिस्ट. जे टाकलं होतं. सो आपण तर त्या सजेशन लिस्टच्याच अकॉर्डिंग जातो. सो लाईक तिथेच we'll be doing that. Okay, moving on. So let's go through this first. कि काय आहे video codec and what exactly are we going to achieve with whatever आजचा जो goal आहे व्हिडिओचा so or streamचा. Yeah, so it's like a software or hardware that compresses and decompresses digital video. In the context of video compression, codec is a portmanteau of encoder and decoder. As a term of encoder and decoder, while a device only compresses is typically called encoder. अच्छा, ठीक है. So basically like zip file कसे असतात तसं आहे ते, but better for dedicated for videos. The compressed data usually conforms to a standard video encoding format. Compression is typically lossy, meaning that the compressed video lacks some information present in the original video. A consequence.
हम्म.
Okay, so video codec applications बघू आपण. Video codec
आता
applications तर आपल्याला
तुझी
बरेच
स्ट्रीम ऑफलाईन दिसतंय.
हो का?
हा ना, आता ऑनलाईन ऑनलाईन आहे.
What? अच्छा मलाही ऑफलाईन दिसते.
आता दिसतंय.
हा आता दिसते. Okay, okay. Nice. Cool. I don't know why offline Kavila, but okay. So I think applications are like pretty common. I think the most common one is H264 H264 video encoding format, which is like used by MP4 वगैरह. Then video codec design. So this is what we want to do. So आजचा तर टॉय एन्कोडरच असणार आहे बिकॉज जे ऍक्च्युअल कोडेक वगैरे असतात लाईक के लाईट और FFmpeg. So that is like a huge and massive project. So just for reference, FFmpeg is this.
हम्म.
I mean, FFmpeg is like a media framework, but Tapan is a video encoder only. Like the core of it is video encoding and video related operations. So like you can use that for this purpose. Commonly used video codecs. Again, हेच की FFmpeg चे जे types है FFmpeg, MPG4 or DivX or whatever. So all of these are the algorithms I think that is used to compress and decompress the video. So like MP4 itself हे नहीं है जे algorithm है ते video encoder है and MP4 is like a wrapper on top of it. So codec packs वगैरह ठीक है. This is not our concern. References, any this and that. Okay, this is fine. So what are the steps to make a video encoder? Let's see. So video encoder. So like at least we know like the basic background of what video encoding is.
हम्म.
Atrocity. Key. Uh, okay. Basics. Come on. A video compression like zip and tar well, but for videos requires an algorithm to compress the video. Okay, I think this is fine. ऍक्च्युली व्हॉट विल डू इज ना नेक्स्ट टाइम जेव्हा आपण प्रोजेक्ट घेऊ तेव्हा आपण तो हे करू 3D गेम इंजिन इन जावा सो दॅट 3D रेंडरर इन जावाचा आपण एक आहे लाईंड अप सो मग नेक्स्ट टाइम लाईक
हम्म.
ऍटलिस्ट आपल्याला ते गोलँगचे तुझं जे इश्यू आहे ना ते नाही होणार की
नाही नाही, जावा वगैरेच नाहीये. द पॉइंट माझा असा होता की मे बी इफ वी स्टिक टू वन स्टॅक, ठीक आहे,
हम्म,
म्हणजे बॅकएंड साठी जर इफ यू नो गोलँग, ठीक आहे, इफ यू स्टिक टू गोलँग, तुझं पण काम ऑफिसचं मोस्टली गोलँग मध्येच असेल. आणि
ऑफिसचं आणि याचं लेट्स नॉट
नाही 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 नाही, अरे ऐक तर नाही, आणि गोलँग इज म्हणजे छान लँग्वेज आहे रे, म्हणून म्हणलं. सो एक स्टॅक मध्ये करून इफ वी काय बोलतात, इफ वी काइंड ऑफ परस्यू टू मास्टर दॅट स्टॅक, तर दॅट वुड मेक मच मोर सेन्स रादर दॅन जम्पिंग फ्रॉम वन टेक स्टॅक टू अनदर. सो हे माझं म्हणणं होतं. बनवायला काही नाही, बनवायला आपण प्रोजेक्ट बनवू ना, नो नो इश्यूज, बट फक्त एक एक डायरेक्शन मध्ये मूव्ह केलेलं वुड बी मच मच मोर बेटर. लाईक कारण की मी जेव्हा आपण पुढे प्रोजेक्ट बनवू वेगळे वेगळे, तर वी डोंट वॉन्ट टू जम्प फ्रॉम लाईक known tech stacks to unknown tech stacks for the sake of exploring.
ओके फेअर फेअर
कारण की कारण की टेक स्टॅक सोबत सोबत द वे वी थिंक, द वे वी डिझाइन ऑल्सो बिकम्स मच मोर इम्पॉर्टंट. तर इफ वी डू दॅट, तर मग कारण की एक लँग्वेज जरी तुला चांगली आली तर तुला हे करायला गरज नाही लागणार, बट यू शुड हॅव समथिंग ॲज युअर स्ट्रॉंग पॉइंट.
ट्रू फेअर
जसं आता करंटली माझं काहीच नाहीये, लाईक पूर्ण स्कॅटर्ड आहे. मला जावा पण थोडं थोडं येतं, मला जावा स्क्रिप्ट पण थोडं थोडं येतं. देर इज नो यूज ना, असं आहे.
बट देन मग आपण इतकं लेंथी डिस्कशन केलं होतं 2-3 वेळा की प्रोजेक्ट करायचे हे करायचं तर मग ते खूप डिले होऊन जाईल.
नाही नाही नाही, तू म्हणजे लास्ट टाइम आपण बोललो होतो, तर तू बोलला होता की आपलं मे बी फर्स्ट मेन एम जो आहे तो आहे हॅक्टोबरला कॉन्ट्रीब्युट करायचा.
ऑक्टोबर फेस्ट
अरे
फर्स्ट लाईक फेज 2 चा एंड ऑफ फेज 2 वगैरे आहे. आपण आता फेज 1 मध्येच अडकलो अजून. सो देर इज स्टिल टाइम फॉर ऑक्टोबर.
हम्म.
ओके.
हा म्हणजे ठीक आहे, तसं पुढे बघता येईल. बघू, आपण नंतर डिस्कस करू, एवढं काही महत्वाचा विषय नाही आहे.
अच्छा.
पण ही बनवू व्हिडिओ आणि
हम्म,
कोडर.
हम्म. See, I don't have an issue with हे, but then तू फक्त टेक्स्टबुक वाचून लाईक त्याचे क्वेश्चन्स करशील then I think that
नाही
is
नाही नाही
something.
नाही नाही नाही, तसं नाही. हे हे करून तेवढं करून तू ऍटलिस्ट त्या लँग्वेज सोबत कम्फर्टेबल होशील. जसं आपल्याला पायथनला होता ना फर्स्ट इयरला,
हम्म,
तेव्हा कोपल मॅम नाही का, नुसतं तेवढं शिकवून त्यावरती एक्सप्लोर वगैरे करून बेस जर पक्का असेल तर आय डोंट थिंक सो काही इश्यू होईल. हे मी तुला फक्त ऍज अ लर्निंग पाथ दाखवलं, पुढे एक्सप्लोर करणं नाही का,
हम्म,
ते आपलंच आहे, काम आहे.
राईट. ठीक आहे वी
मला
कॅन.
म्हणजे सांग, तुला काय वाटतंय, तुला असं काही म्हणजे काय बोलतात, जर असं चेंजेस वगैरे वाटत असतील किंवा मे बी त्याकडे डिफरंट पॉइंट ऑफ व्ह्यू आहे जो बेटर आहे, तर सांग बाई कसं काय.
ओके सो लेट्स सी आपण डिस्कस करू नंतर.
हम्म.
आधी तर जस्ट लेट्स लुक ॲट एन्कोडिंग. हा मला ब्लॉग मिळाला इथे सर्च करताना की व्हिडिओ एन्कोडिंग स्ट्रीमिंग developers guide. So let's see. Encoding is the process of compressing raw data frames into a deliverable format using a codec. So uncompressed basically pixel data given, we compress it and then we basically transport it, right? You're decoding a file and re-encoding it usually to change codec resolution, bit rate. Okay, so already encoded source person, you start the transcoding. You're decoding a file and re-encoding it. usually to change the codec resolution of bitrate. Most encoding pipelines in production are technically transcoding pipelines because source files have arrived pre-encoded. Okay. Packaging is the step developers most often forget. Transcoded file is not streamable. Okay. Packaging takes our encoded input and segments it into small chunks, then generates manifest files that tell a player which segments exist. Okay. Oh, okay, understood. So like there are three steps to three different things inside codex as well. Achha, this is like a sort of de-ambiguation or disambiguation the author is giving. कि ये तीन गोष्टी different हैं, not the same, which is fair. Let's see containers versus codecs. So this was something I was saying before. कि MB4, MOV, and MKV are containers, not the actual this thing codec. So codec is H.264, H.265, AV1. These are the codecs. An MP4 can contain H.264 video. It can also contain an H.265 video. The container does not tell you the codec. Okay. This is why FFmpeg flags like CV libx264 specify codec separately. Okay, understood. Okay, things you need to know. Bit rate, how many bits per second the encoded stream uses. Okay, good for live streaming. So this is what we worry about, right? While live streaming, the low bit rate पे जाए or latency should be low. Bit rate, having it low helps. Variable bit rates allocates more bits to complex scenes and fewer to simpler ones. Better for word quality per bit. Okay, fine. Keyframe interval, profile level encoder preset. Okay, understood. So I think uh, this is just good to know. Codec trade-offs, 40-50% better compression, real licensing pain. Okay, so this is hmm, fine. Serial cost equation, segmentation, duration trade-offs, per title encoding. Okay, this is just sort of talking about encoders, not how encoders or what are the components of encoders. I wonder what is a video encoder? Nah, DIY streaming stuff. No, what is video encoder? Okay, this is ass man. Current there is no actual. Okay, I guess we'll just have to rely on GitHub to understand how it's done. ठीक है. Before we take a look at this thing, uh, the actual what do you say code on GitHub, वगैरह, we'll create like a new this thing branch. So week 2 uh, video codec. Nice. Okay. So I mean I have pushed this branch to GitHub. So एकदा प्रतीक maybe हे करून घे and like तुझ्या याची एक ब्रांच क्रिएट करशील like जसं week 1 मध्ये केलं होतं तसंच.
राईट करतो ना.
Nice. Okay. Nice. Give me 1 second.
हॅलो.
हा बोल.
अरे तुझं हे विजिबल नाहीये. हा आत्ता विजिबल आहे. कॅम ऑफ केला होता.
अरे हा माझं डोर ओपन होता तर मग मी डोर बंद करायला गेलो. Anyways, okay. So we are on the correct branch. Hmm. FFmpeg. Yeah. I want to make code. How to do that? Components of code. So okay, we are just getting the same this thing. Oh, nice. So there are very CUDA-based video encoders as well. Nice. Okay. Um, okay, I think. Nice. Comparison of codecs, displays resolution, multiplexing, sampling rate, transcoding, and video quality. Let's see how to make a video encoder. So let's first understand the video. How to make one. There is no one. Take it. We will just use this particular video. So then even what they've done is this key. They have used the stock video from this source or whatever, and this is the singular, I think, Golang file जिथे त्यांनी code लिहिलाय. So I think just reading, I will have to first read the code. Current, I don't know what a video encoder even is to begin with. Like what I basic, just I know, just the basics that I know are की त्याच्यात spatial compression होता, मग we use the DCT transformation or direct cosine transform to basically uh, do some do some stuff. So let's see how that goes. Okay, is this okay? I think it is visible. Yeah, cool. Okay. Do-do-do-do. Hmm. Let's just okay. Fine. I think the least we can do is just go through this. This script shows how to build a basic video encoder in the real world. Video encoders are a lot more complex than this, achieving upwards of 99.9% compression. Okay, so this will just show 90% compression, which is fine. Like for normal people like me, this is more than fine. Fundamentally, video encoding is much like image encoding, okay, but with the ability to compress temporally. Okay, yes, what temporally means is across time periods. So like T1 to T2, J whatever video content है, it will compress that. So okay, image compression often takes advantage of the human's eye's insensitivity to small changes in color, which we will also take advantage of in this encoder. We will stick to older techniques and skip over modern ones that involve a lot more math. This is to focus on core concepts instead of getting lost in the optimal encoding approach. Fair, fair, fair. Let's see. Okay, so he has taken bytes, compress slash slate, flag, IO, logs, and OS. Okay, so compressed.flate, I think, is the Golang package that basically has the Huffman, basically the compression algorithm that is used in zip files, right? This thing has that as a function. If I'm not wrong, I think this is used in like compressing some frames or deflating. Like I think it's for compression somewhere. Let's see. Okay, fine, never mind. So, okay, so they have two flags, width and height. Okay, okay. So I think I understand why they have flags here. I think it's like the raw video, जो इथे है, that one actually doesn't really have. It just has raw data. It doesn't come with like a header that says, "Oh, this is the height and this is the width." So fine. So we read raw video frames from STDIN in RGB24 format. Each pixel is 1 byte. Okay, so it has so it's lined up of pixels side by side. And each pixel has three values, RGB. So total size is width times height times three. Right? Three three because width and height will be for R, G, and B. Three of them both. Read the frame from stdin. Okay, so you read this entire frame, we get the raw video. Okay, first we will convert each frame to YUV420 format. What is the YUV420 format? Looks like this. YUV looks like this. Okay, YUV, YUV. Fine, but what is YUV? YUV color format is used in video compression. that represents Y, Luma component, and two Chroma components. Okay, Chroma and Luma, YUV format. So from what I understand is Luma means luminance and UV is chroma, so it means chrominance. What does that mean in this context? Mala zero idea, man. This format is commonly
ल्युमेन
used.
म्हणजे इंटेन्सिटी ऑफ लाईट ना.
Right. So Y is brightness and U and V are color channels. That I get, but what does it mean? Like what does it mean in terms of a video? ते मला माहित नाही. So let's see. Uh, Planar YUV formats. About YUV format. YUV values. Okay, bro. It looks like Kai Y1, Y2, Y7, Y8. Why is this? Oh, okay. So it's like कि एका color चे और एका group of pixels से you just keep individual brightness. So Y1, Y2, Y7, Y8 and the color values are stored here. And then they do that for U2, V2 as well. The color values are stored here and all the intensity values are stored here. Damn, that is crazy. So they are literally.
ब्लू वाले इज कलर्स.
एक मिनट. Let me copy this image. So from what I understand is कि this is basically like compression, but like a very different form of that. कि like this Y thing here, त्याचे colors actually इथे stored है, but this is just the light level because humans are more sensitive to light levels rather than colors. So like you can tell the difference between light pink and dark pink much better than the difference between pink and purple. I think is what they are trying to say. I mean, if you can't tell the difference between pink and purple, you're like colorblind. And basically, what I mean to say is कि color just shades, instead of differentiating between shades of color, the human eye is better at differentiating the brightness of color if it is light or dark. So that's why I think they are keeping the intensity values here आणि जे color चे actual values है for these 4 pixels they are just storing it in 2 pixels. I think that's what they're doing here as well, right? In the green one because hey y चे values are luminance values and UV is the chrominance value. Same for yellow, same for the orange or terracotta ones. And then purple साठी पण same है, yellow साठी पण same. That असं store केलं आहे the whole thing. Okay. Okay, I think I understand it now. And then this is like the position in byte stream key. This entire grid is transported like this y1, y3, y7. So first all the these values go y values, then u values, and मग v values. And I think if I'm not wrong, even these are compressed using Huffman encoding and LZF or LZZ, whatever. जे zip files मध्ये compression वापरतात, this whole thing is compressed again. So that's how we get like 90% or 99.9% compression. Absolutely crazy. Uh, okay, so I think this was the question. No, this is fine. U samples, V samples. So this is generally how YUV format goes now. YUV 420. Wait, what did he say? Diagrams. Okay, fine. I think this. So this is what we are going to use to compress our shit. YUV is a separation used in PAL. Okay. Hey, मला काही कळत नाहीये. What does this mean? Related color models. Because I think cable TV in some regions या फॉर्मॅट मध्ये येतं. माझ्या घरी इथे या फॉर्मॅट मध्ये यायचं.
हे 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 मला थोडं थोडं आठवतंय, हे केलं होतं कम्प्युटर ग्राफिक्सला.
अच्छा, आम्हाला नव्हतं कम्प्युटर ग्राफिक्सला. जस्ट आम्हाला RGB आणि MGYK वाला मॉडेल होता. मजेंटा ग्रीन येलो वाला. So we had this thing RGB वाला which is a reductive model आणि additive model. दोनच होते. The YUV was not. Yeah. हाँ, अरे नहीं, हे इथेच दिलंय ना. YUV is the color model found in the PAL analog TV standard. तसंच that's what I meant की हे मी बघितलंय. टीव्ही मध्येच येतं की त्यांचं ओके. बट इथे पण सेमच दिलंय. Okay, prime denotes that this is calculated from gamma corrected RGB input. So RGB was when this is calculated. That's why it's not true luminance. True luminance. Okay. Because RGB is actually a subtractive model. All colors add के लिए RGB मध्ये so you get black. So it's not the true luminance. It's like almost inverse of luminance, which makes sense. ठीक है. TV formats and blah blah blah. Luminance and chrominance systems in general. Um, CIE, chromatography, whatever chart hota or something. I remember this relation with Y prime CBCR used as a term for YCBCR. While related, these are different formats with different scale factors. Okay, fair enough. Chroma subsampling. Encoding images by implementing less resolution for chroma information than for luma information. So we are going to do this is what we are going to do, na? Ki we are going to keep the color information lower and have the luma information higher. Like luma, whatever Y intensity is there, that we won't cut as much. We'll just cut out the colors आणि मग त्याला आपण स्टोर करणार आहे in a different way. How subsampling works? Subsampling तर it's like grouping of something and I think that's it. You form groups of pixels and for a given 4 by 4 or 2 by 2 or whatever grid of pixels, we basically store the same value of color. Okay, let's see. The human vision system processes color information at about a third of the resolution of luminance. Therefore, it is possible to sample color information at lower resolution while maintaining good image quality. This is achieved by encoding RGB image data into a composite black and white image. Huh. Y prime CBCR RGB. Okay. Okay, so subsampling is fine. What are these ratios? Sampling system ratios. Bro, what? Okay, मला तर हे काही कळत नाही. So what does the sampling ratio mean? Like sampling in that grid की
I
4, 4, 2, 2.
my God.
अरे हो, but there are a lot of steps in encoding. And this is just a toy encoder. जे, so from what I read, इथे, right? I think in the README only, it's like given key. This is just in 120 lines of code. It's like an exercise rather than a comprehensive guide.
Mhm.
So it is just 120 lines, pretty short, but so it does all of these steps. So I think at least knowing these steps is quite helpful. नाहीतर मग it would काय केलं काही कळणार नाही. Mm, types of sampling, subsampling, 444. Three components have the same sample rate, thus there is no chroma subsampling. This scheme uses high-end film scanners in cinematic post-production. Okay. So this, I think what this means is no subsampling, only sampling. 422 chroma components is sampled at half. Acha, okay, I understand why there are three digits here. Ki this this the first one is Y, second one is U, and third one is V. Manan, it's like always Y is greater than these two because we want to keep intensity and forget color. This reduces bandwidth of an uncompressed video signal by one third, which means for 8 bit per component without alpha, only 6 bits are enough. Okay. Many high-end digital video formats use this scheme. Acha. And 411. I think this is like the bad one. 420. CBCR channels are only sampled on alternate line in each case. Vertical resolution is halved. Data rate is thus the same. This fits reasonably file with PAL color encoding scheme. Oh, damn. So 420 is what everyone uses. WebP, VC1, JPEG, Apple Codec, DVCam, DVD, PAL, ISO, MPEG, whatever, Blu-ray. Okay. So the entire world uses this 420 subsampling. 411 है and if 422 है. 422 is like Any high-end digital formats use it. आणि 444 is like movie मध्ये. Okay. So I assume this is like in IMAX 3D वगैरह मध्ये this type of sampling must be used. Not sure. I feels like it. Anyways, so 422 is 24 bit per pixel represented in 16. Okay. Yeah. Horizontal sampling is doubled. But CVCI channels are only sampled on each alternate lines. Okay, fair. Interlaced and progressive with interlaced material 4 to 410. This ratio is possible and some codecs support it, but it's not widely used. Ratio uses half of vertical and one-fourth of the horizontal color resolution with only one-eighth of bandwidth. Maximum okay. Okay. So there are damn the इतके सगळे subsampling चे methods we have to select one. I think one has already been selected for us by the author, but good to know. Gamma luminance error. Mm, gamut clipping. Mm, okay. Chroma subsampling. I think this is it. Color space. This. Yeah, I don't think lossless data compression method. Video concepts codec. Oh, अच्छा there are positions also given here. Okay, let's check out what's the code. So now we know what YUV 420 format looks like. The gist of this format is that instead of components RGB, which each pixel needs, we first convert it to a different space, Y luminance and UV chrominance. The way to think about this is that the Y component is the brightness of the pixel, and UV components are the color of the pixel. Ah, right, that's exactly what he said. UV and four adjacent, so we only need to store them for four, uh, each for 4 pixels. Okay, fine. Yeah, hold on. If you're seeking more resources, YUV format is also known as YBCBCR. Okay, it's close. Actually, that's not a so I think we read this. Ki YUV is not the same as this, although it is called that. And yeah, by convention, in a byte slice, we store left to right. Okay, so we convert the pixel from RGB to YUV. Um, Raw size of frames. IO.read full. This is the input point. This is from where we are reading the thing. एक मिनट. I'll be back.
Hello? 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 Hello?
Yo, what's up, guys? We're back. I had to step out because I have some things to do. My bad for stepping out, but it is what it is. Anyways, let's move on. Okay. So last time before we left, we basically read the two different formats and a bit more about subsampling and sort of. Yeah. So I think we read about the RGB 420 model, how it handles stuff. So let's see. Okay. Um, the gist of this format is that Habla. This is hmm. Let's moving on. Now we know the gist and all for the format that we are converting into. So this is going to be encoded or converted into this format. In practice, this doesn't matter because our image will be transposed if this is done backwards. Okay, so what does that even mean? Uh, UV format is also known as YBCBCR. Hmm, that is not completely true, but it's close enough. By convention, in a 1 byte slice, we store reading left to right, then top to bottom. That is, find a pixel at row I, column j. We would find the byte at index I times width plus j times 3. Okay, understood. This is fair. These coefficients are from the ITOR standard. Okay, let's first take a read for this. What are these RGB code? Actually, this is the index now. Okay, but 3 times j, 3 times j plus 1, 3 times j plus 2. Converting the pixels. What are we talking about here? Conversion from RGB. Okay. Oh, so you multiply those values with that. Is that the case? Hmm. Hmm. Yes, this is what he's talking about. Yeah. So this is fine. This is just the normal this thing. Your uh, counters for the loops. So we are going from this to width times height. because we want to have each and every pixel inside. Okay, fair. Fair. Now we will downsample the UV components. Okay, so there's sections to this. Um, and is it like all in one big for loop? Uh, yeah, so that's what I'm not able to understand unless and until we look at the entire code. Is like, what is the deal here? Is it completely under one for loop? Can we split it into multiple functions? So it's like easier to understand. So, okay, YUV constants are given here. Store the YUV values in a byte slices. These are separated to make the next step a bit easier. Um, extend this one. Is that more that converting to AUV allows to us to downsample color space efficiently? Okay, yes, we know this. That basically converting to IUV allows us to convert this thing more efficiently. Store the YUV in our one byte slice. These are separate to make the next step a bit easier. Okay, store the YUV in our byte slices. Um, Store the downsampled U and V in these two slices. Downsampled V downsampled. So yeah, that makes sense, right? Because the downsampled U and V you're storing separately here, and what are we doing there? Putting the U and V in this. V downsampled, then okay, what is this calculation though? Uh, because we are just making U over here. This point U is not. Yeah, so it does. Okay, we can at least what we can do is we'll start writing the code now actually because it's been like just too long. Okay, just reading about it. So let's go. We'll take it out and hmm, okay. We'll add the flags here as well. Uh, for flags, what is it? Yeah, click int var flag dot int var. Int height, uh, width. Yeah, say I don't know what the default I should do for height. Let's say 1080 usage. No information available. Okay, let's do more. Oh, we never did go wrong in Is that fine? Um, Name of it is this thing, right? Video coder. We go multi-ID. Let's see if we have it. Inspected. Right. Oh yeah, this is all wrong. Um, we do var int height. No, var height and then we get int. I think yeah, this is fine. And then same for width. Also, I think it's the and sign here. Yeah. Okay. I hope. I am not sure. Can we use multiple? So I think let's just say because saying H is not not really useful. Height of video stream width. Let's see. Okay. So at least our flags are defined. That much I think we can do in the main function. Yeah. What is this? Just reading the raw frames. Yeah. So I think we can make a function here. Read frames. Hmm. I don't think we need anything. We just need to return the slice. Yeah. By okay. This equals make. Maybe this is by, and we put one zero here. For what for do we do here? Width times height times 3 is correct. Yeah. Okay. Hold on. 1 second. Mm, okay. So frames, yeah, append is the only option. It can be set like what we want is uh, if no, how to read. I know the answer is just there, but there's no point in what we can do is read IO full, right? Reads exactly, yeah, IO dot reader. We want an object for IO dot reader. So uh, I think it's going to be stdin because what we're going to do is we're going to do cat xyz dot RGB24, and then we are going to pipe this into the go main.go or go run main.go. Yeah. So that's why it's stdn and buff byte. This is going to be a, but I want to append this and be append slice, you know, the, if frame equals nil, frame the same byte and size needs to be something. Frames can be actually width and height, no? Width and height times 3 or this will be 0. Need to take the width and height here as arguments. Mm, this is int. Mm, uh, frame times 3. So wait, what does readful reads exactly len of buffer from R into buffer. It returns the number of bytes copied as an error. If fewer bytes were read, it returns number of bytes copied in error. If fewer bytes were read, the error is EOF if no bytes were read. If EOF happens, oh, if mm, wait. So underscore, and then if OK equals 0, then OK, 0, that would make sense now because then 0 bytes are copied. Or let's see, I'm not sure about this. Uh, okay, okay, so this is like that's why it's and then here we'll break, and then here is append in the frame, right? Yeah, I think where's the okay? What I'm wondering is there is it's not popping out. I'll just have to use my phone live chat to see if there is someone now. Okay, fine. So we have done like the read frames thing, or we have to return frames. Yeah, so we have read like the frames. We can also fmt f size of video stream input video. Uh, say percent %d and then we do its size of the frame, right? Its size or how do you get frame start? Mm, Size, undefined size. Okay, how do we get size of frames? Where how to get size of a slice, right? In Golang. Len function may to get the memory used by a slice in Golang. Uh, well, len size of element. Okay. Uh, we'll just write it here, right, to show size of frames. Okay. So our read frames function is complete. So Now we can, yeah, so this is what I was trying to do, but that's fine. Raw size or whatever. So I guess they have a function for this itself, which is okay, whatever. So now we'll convert each frame to YUV 420 format. Okay, so I think this conversion is like one full step, or okay, this is done and it's still in the for loop. Yeah. Oh, see, this can be played also. Encoding, then what are they doing? Okay, hold on. Let's go to our this page. Okay, now it's hold on. Okay, I'm back. Hello. Okay, good, good. Is he playing? Okay, my. Oh, flashbang before the audience. Wait, I hope my. Like, this is visible. Oh, good. So the audio is visible. No, it was just that. Okay, great. Cool. Okay, guys, let's continue. This is fun. Okay. Uh, how to do the plan? Okay, so the first thing we do is we read the file. Then read input video. Okay, that step we have completed, correct? Now, second step is going to be spatial compression. And so spatial compression is basically that YUV 420 format conversion. That we'll have to do. So I think this entire section is that only, but they are also downsampling it. So they're doing two things. They're actually three things. They are doing the YUV 420 conversion. They are also doing the downsampling that we saw here, chroma subsampling or downsampling, this thing. That is being done. And we will downsample UNV. This is a process where we take 4 pixels that share UV components and average them together. Hmm. Now we need to store YUV in a byte slice. Okay, what does that mean? Oh, they're like putting the YUV Y first, then U downsampled and V downsampled. Is that what? Yeah, okay. Looks like that. Yeah. Hmm. Okay. So basically copying all of this data into one singular frame is what they are doing. So downsampling plus conversion. Yeah, that's what I can see. And then they have it in like a planar form, a flattened form. Yeah. So you have convert RGB to YUG. Um, Convert RGB to YUP. Also downsample UE. Let's have another. Yeah, flatten. Single slice. So we have broken it down into multiple chunks. Okay. Okay. So this is like the first sort of half. Out of this, we have completed this. All of these get to be completed. Oh, why is the background like this one? Hmm. Okay. So these three are the uh, goals basically. This is what we want to accomplish right now. Like immediately, this is what we want to accomplish. These three things here. Convert RGB to YUV, downsample QV, and flatten in a single slice. Right. So how are we going to do that? They have made three arrays and converted them. So let's look at how to convert from right SDTV with BT470. Okay, so this is like uh, some constants or what is this? Oh shit, it's like matrix multiplication. YUV signals are typically created from RGB source. Weighted values of RGB are summed to produce Y prime, a measure of brightness or luminance. Q and V are computed as scale differences between Y prime and the BR values. Hmm. Is the learn mode still here? The hell? Okay. Whatever. Fine. My UV plus this weighted values of RGB are summed to produce Y prime. PAL includes use this. Um, okay. Okay, I think it's set now. At least I can see the chat now. Hmm. Okay. Converting above transformation converts YUV to RGB. So Y equals WR plus WR times R, WG times G prime, WB times B prime. Okay, what is prime? Why are you Y prime U, what the hell, man? What the hell? R prime, G prime, B prime. What is R prime, G prime, B prime? It's not given here. So these are basically the constants that you want with R prime, G prime, and B prime to get your values. Okay, I understand it now, but um, fine, we can at least have all of these written now. Let's have a function. Um, read, like, convert RGB to IUV. What will we take? We'll take width array. What width is int, height int, and we will also take the frames. White frames. Um, and we will return a flattened yeah. So for now we will return nil. Okay. What is the issue? Unused. It's fine. Wait, what? We don't have the oh nice. So since the new frame has RGB means um no way. Does it return zero if reads exactly len work bytes from R to buffer, returns this on the return len of buff if and only if error is equals to nil. If R returns an error having red is dropped, if an EOF happens, read full reads. On return, n equals len of buff if and only if error equals okay. Oh, wait. So it says here key on return n equals len of buff. Okay, wait. So actually, this is old town. This is error. Why is the thing moving? Nil. Oh, error equals nil. That's what we want. Yeah. Okay. Yes, so anyone who does not know about Golang can at least understand that. Yeah, this is what we are doing. Returns. Error, um, convert. Yeah. Okay. So first thing, the constants. Constants. WR. What is W? WR is 0.299. WG is 0.587. 0.2. Yeah, 587. WB 58711443665. Wait, what? 114. 114 Umax equals 436615. 6615. Yeah. So we have just that time. Okay, now I think the font at least is a bit bigger. Man, low key, I might just open VS Code because this is like moving too much. Oh, or is it not? Oh, no, it's on stream as well. Okay, I might have to. Yeah. I don't know why is it doing that. It shouldn't. Uh, okay, letting my phone charge. main.go and okay, I think yeah, everything's cool. I mean, it is memory hog VS Code, but whatever, man. Fine. Uh, what is this? Some audio capture things from movies. News. Oh, oh, I lost my file folder. Okay, right. So, converting here, yeah, we just have these constants outside. Where we don't have a formatter here. Hmm. Format. Inclusive install formatter. Go. Yeah, this is my first time setting up VS Code on this device. I already used on quite a while. This is fine. This is fine. Okay. No formatter for Go installed. It is installed now. What? Open the VS Code extension, blah blah blah. Okay, it's still installing. Okay. In the meanwhile, man, Oh, I think it kicked in. Yeah, yeah, yeah. Ready to go. Ha, funny. It's coming up. All the problems. Core lens. What's it called? Kit lens. Code actions. Yeah, I don't know. It basically shows your options and issues here. Whatever, fine. Convert RGB to YUV. We have those constants now all sorted out. We have written all of these. Okay. Inverting the above transformation converts this, but then what is R prime? Weighted values of RGB are summed to produce Y prime, which is a measure of overall brightness or luminance. U and V are computed as scaled differences between this. Okay. Mm, Chroma subsampling. What I don't get is we just multiplied it like this. Mm, This is the conversion part now. So yeah, you have three arrays of YUV. You have RGB. Oh, this is the value from wait frame. Oh, so you iterate over all the frames. It makes sense. Then frame of 3 times J. That gives us the B value or R. R value is the so wait. Oh, okay. So is it like that? Like it got inverted 3 times J plus 1, 3 times J plus 2. No. अच्छा नहीं. Okay, I am stupid. It's just so it's like अगर zero होगा तो this will be zero, this will be one, this will be two. So it's like yeah, it's a smart counter sort of. Um, Okay, that is stupid, man. Yeah. Yeah. So they will be converting this into y 0 comma 0. What does that even mean? The UV components are shared between four adjacent pixels. Yeah, so this is what we were talking about now over here. U and V components are shared by four adjacent pixels. Yeah, so Okay, so for these four, the use will be this. But how do we get the four adjacent pixels? Because it always has to be something like this, right? How do we know that it's a 2 by 2? So, or a 4 by 4? How do you know that it's always a 4 by 4? We don't, right? If you're seeking more resources, YBCBCR, let's see YBCCBCR. What I don't understand is due to number of existing TV sets and cameras, existing black and white. Because of this backward compatibility system, okay, so damn, so this is actually backward compatible with, that's crazy. A color image, and it's Y prime CB and CR. Oh, okay, so it's like it's color R is this. This is the color blue, and yeah, it is quite damn. I think I have the brain also fills in the gaps here. Yeah, damn, that is crazy. Because this is like a good image. Yeah, keeping that. Okay, compatible color. Hmm. Yeah, they are practical. My prime series here. Okay, conversions. RGB to yo. Why? Why can't you make it easy? Also, what is R prime? So I'm just going to assume that okay, let's see, RGB to this. Okay, looks like these are gamma adjusted. What does gamma adjusted mean? Gamma adjusted. Also, damn, this is like hidden. Right? There is no straight up article that tells you oh how to make XYZ this thing video encoder. You literally have to find it, and even then, it's like not very clear. Gamma adjusted RGB refers to process modifying RGB account for non-linear way that monitors display brightness. Okay, so from what I understand is it is so that the shit, the things that you're seeing, it appears better because the human eye interprets color not exactly as the color exists. Gamma equals 1, gamma equals 2. Also, this is kind of scary. Is someone floating in the water? Why do you have to take an image of this, man? The effect of gamma's correlation, correction means just take into varying powers, showing that powers larger than 1 make shadows darker, while powers smaller than 1 make dark regions lighter. Powers smaller than 1 make dark regions lighter, and powers larger than 1 make shadows darker. Yeah, that does make sense. Mhm. Okay, so it is a non-linear operation, blah blah blah. Optimize usage of bits. Okay, power function, which is no relation to the gamma function with greater sensitivity to relative difference. The consistent. Okay, we don't want to get into too much detail, but from what it looks like, gamma correction is just an optimization trick, and it also makes it so that the color itself is corrected in a way that it's better suited for human eyes. Again, I think what it means is it just takes into account luminance more rather than color. So yeah, RGB to YBBP, blah blah blah. We are not doing this conversion, so I think there's no point in looking at it. Okay, yeah, this is fine. Let's go back here. By convention, our inner byte says we store reading left to right, then top to bottom. That is to find a pixel. Okay, so let's start at least the basic logic where we have y in right of, I think just single byte. You have to be width times height now. So this is u y u v, all of them have width times height. Oh, but why is this should hmm, why? Oh wait, why is this float 64? So U values can be okay. Hmm. I was going to see this conversion. So it's 0.299 R plus WRR, WGG, and WPB. The R as times G B and plus times B. Now we don't have. First, let's write this. We have U. We have U, which is also from of U. 492. What? U max times 1 minus. We have U max times B minus Y. 1 minus WB. Okay. And we have V last. I'm definitely the least. V max RY 1 minus WR max R. Wait, this R minus Y. What happened here? Oh, 1 minus WR. Okay. Now we need to also get this thing, right? The for loop for string strings. Sorry. Yeah. Okay. Oh, 0 I is into Right. Right. I think then I just pass something over here. Mm, frame of uh, okay. R equals frame of three times what's the issue here? Cannot index variable frame. Why can't we index it? Mm, mm. Yeah, I just remembered that we need this thing for the the height as well, right? Basically, to figure out where the pixels are above or below, we need to figure out on what frame or what row of frames we are, so we can actually move through that like a grid. Okay, 3 times I, we have G, that is 3 times I plus 1, B, minus 1. This is right, yeah. Okay, but I don't understand what's the issue with the constants. Anti-constant truncated to byte. Oh, Vmax is a function. Hmm. Oh, okay, no. It's because I didn't multiply. I truncated to byte. Um, what does that even mean? It's truncated to byte, which I understand. What do you want me to do? It's supposed to be 464. What? Mhm. Untyped float constant, truncated to byte. I literally, huh, this is not any sense. Huh? WR Like what am I supposed to do here? But that's not helping either, no? Five, 8, 7. Okay, that's um, Golang. What does this mean? Conversions are required when defining it. Okay, okay, understood. So we want this to be float. Is that it? Var C. Oh, okay. I understand it now. It has to be of the same type. So yeah, so what it's like trying to cut it out. So 64. Byting float 64 mismatch types. What the heck? Why does it say that it's mismatched types? Oh, okay, okay, I understand. I understand it now. We messed up. So the thing is that the frames array here, this is bytes, and then we never converted this to float. Yeah, yeah, I think that's the issue. Okay, anyways. So what we want here is float 64. Mm, yeah, so I think this should fix it. Yeah, this fixed it. Yeah, it was still byte. That was the reason why. Hmm. Okay. Now, so we have converted actual, we have found like the actual maths for the conversion, right? Let's see. So this was the only thing that was actually required. Now you can copy. Why is it saving it? Image, put it here. All the images are transparent PNGs, so you're getting a bit. Yeah. So technically, this conversion is done. We have to do like the downsampling now. Okay. So yeah, that was actually pretty simple. So I thought that it would be a little challenging, but yeah, it was literally just the formulas. Yeah, I think this should be right. Yeah. Okay. Yeah, I am a college student. I like this. If that's what you mean. Yes, sir. Uh, okay, moving on. Okay, so he is now putting this in byte slices. Okay, these is getting stored in this byte slice. These byte slices. Okay, understood. Huh. J. Okay, back again. Yeah. Okay, nice. Yeah, let's get back to it. So we just finished converting this to YUV. Um, let's let's add all of this to the slices. So V and then this will go to V. Okay, so this is the conversion that is done. Um, the thing is that since actually we'll have to convert. So wait, what happened? Okay, okay, convert iframe this to this. We also want downsampling. Uh, so this uh, yeah, u down u sample byte. Okay, so our this thing is going to be 4 is to, I think that's what, excuse me. Is there even like a sampling rate? Standard one? Yeah, 4 is to 1 is to 1. Yeah. So this is the subsampling that we will be using. I'm pretty sure because hmm. Okay, what is the chroma sampling ratio for YUV 4? Oh, it literally says 4 to 0. Okay, my bad. What yeah. Okay, mistake. But then what? I don't get it. Then UV sample. Mm, so will it go alternate or take? That's a good question. So let's see. So the 4 to 0 horizontal sample double compared to this because but as CVCR channels are only sampled on each alternate line. Okay. So this, okay. The vertical resolution is half, the data rate is thus the same. This reasonably fits well with the PAL color encoding scheme since only half of vertical chrominance resolution of NTSC. Okay. So this is like the historic thing, right? Since this is only half the vertical chrominance resolution of the NTSC, it would also fit extremely well with the CCAM color encoding system. Mm, Transcoder to convert manual CCAM. Okay. So basically, PAL is the most common in the world. CCAM and all, but whatever. The main thing is that they all of them use the format that we are doing. Horizontal sampling is doubled compared to this, but this is only sampled on each alternate line. So vertical resolution is halved. The data rate is thus the same. This fits reasonably, blah blah blah, and this is what like FFmpeg and all basically use MPEG or yeah, H.264. This is exactly, yeah. This is like the most common one, right? So I think that's why this is used a lot. Okay. Yeah, so that's the thing that I was relating, right? So it has 1/4 of the chroma bandwidth. The chroma bandwidth I thought is 1/4 for this as well, and this as well. Um, yeah. Anyways, fine. So it's 4:2:0. Chroma sampling ratio. You uh, we U downsample and V downsample. The height and width is by 4. So what do we do in downsampling? First, let's understand that, right? What we do is we take these and so we are here. For this whole sort of adjacent 4 pixels, we want to just capture these 2 pixels of this thing. So I think what we have to do is we have to go to all of these 4 pixels and then take average of the U and V values, right? Because there's only one U value and one V value for this. Hmm. Okay. I'll just There we go. Now this is clear. This formula is also clear. Um, okay, fine. So, hmm, the horizontal assembly is double compared to this. Okay, I'm closing the chat for now. Look at it. U and V are downsampled here. Okay, we were here. Now in downsampling, what we are going to do is, okay, so first we'll have to traverse the grid, GERD, traverse the GERD, go to this part of the this thing. Basically go row by row and average out the 4 blocks. Okay, okay. So I think we will be, I understand it now. I understand now. Right. So what we are basically having, right, is a sort of a this thing, a 4 by 4 filter, like a convolution we have in a neural net. So it's something like that, where okay, one second. Okay, What the heck, man? Never mind. So what I'm trying to do with all of this shenanigans is to just really emphasize this point to myself that this is like a 4 by 4 grid. Okay. Uh, okay. So okay, this feels like a little bit too much now. But anyways, what the whole purpose of this is that here, right? We have the y values. We have the y and the y u v values for everyone here. Same for this also. V and u and y, right? So what we do is keep the y as is and average out u and v so that u of I equals average of whatever this like thing is key u 0 comma 0 u1 u2 u3 u4. Four, no, sorry, three, two, this will be four. This is two, this is two, this is two. So this is how we go down, right? We go left to right first, and then we go down, and then we go left to right again. Same goes for V of I, average of 1, V2, V3, and V4. Whoa, whoa, whoa. Okay. Oh, what's wrong with G? Yeah, a G is never used because of this. Y also got deleted for some reason. Yeah, we have the formula right here. So it's WR times R plus WP RGB RGB. Yeah. Okay. Basically, grade the average cooling for U1B. This is how I'm interpreting it because that's how my brain sort of finds it, better to articulate it. But yeah, so let's do this now. R and row and column, or X and Y, or whatever. X is so X is less than height. So this is row, right? Because it's from yeah, this is the row. No, because X and Y for me is like confusing a bit. Because you then think of it as Cartesian coordinates, but it's not. It's two. Uh, okay, for C equals 0, C is less than where C equals to. Okay. All sorted. Um, Now we want U and V again. U we were declared in the other block, so this is fine. But yeah, I think UI is better. U of first ever is going to be divided by 4, whatever we get. Because I mean there's going to be 4 values of U, so it's 4. And then U of row times width plus. So right now R is going to be 0. So I think this is correct. Plus, and yeah, column is also going to be 0. So this is going to be the top one. Row plus width, so that row times width always, because we don't want to step on something that is already this thing done. And then column, you're incrementing by 2, so that should be fine. Column is always going to be 0. If column is 1, it will just move one more side, right? So that's fine. Plus U R times width times C is 1. Just in the end, it's like a plus 1. Uh, so this is the next one. Now it will be U times U of the R plus 1 because it will be the next row times width plus C. And the same thing here, we just C R plus 1 times width plus C plus 1. So this entire thing will, the same thing for V also. R um, S U. Okay. Yeah, I think this should be fine. I mean, U and V is same this thing after all. So yeah. Okay, so then this UI and VI, once we get this, we want to store this in an array. So this is going to be that slice. Alright, so this slice, you desample x by 2. Okay, let's see. First of all, int 8. This is only because I think we did the same thing for y, and these are going to be merged into y here. So here we do ui, we do v, and we do vi. Okay, great. Now you desample, we desample this. We could append, no? Is appending correct? Uh, the the issue is it's not. Um, is it? Mm, 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 mm. Uh, No, because what I'm thinking right now is this could jumble up the pixels, no? Um, if I append it, will it jumble the pixels up or no? That's the main question. Mm, because no, so R is the this thing width. Hmm. Hmm. How do we? I could look at the code, but that's again. Hmm. I don't I don't understand it now. I don't get this. So okay. This is how do we want it to go in the UD sample? Because right now what I'm thinking is I can just do this sequentially, right? And it will be fine. But then the thing is right to left to the uh, 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 hmm. Yep. So I think this is like the best workaround since actually shouldn't it be four? Since oh no, it's height and width by four. So row and yeah, this thing is by two only. It's by two, which makes it four. Makes sense. Yeah. Yeah, I think this is pretty simple, right? Because it's 420. You just do half the width and half the height. Yeah, this is good. YUV. Okay. Okay. So I think downsampling is also done. Downsampling is completed. You just now we just have to flatten it to a single slice. Okay. So mm, mm, no marker comments. Where are the this is in comment composer all in one. Uh, okay, nice. This is what I was talking about. Git lens. Fine, you don't want this. PowerShell. Um, share the oh, what is this? Community. Save up to 50%. The hell? What did? Okay. Chill. Compose commits. Launchpad. Start work on an issue. Uh, what is all this? Uh, I'm getting sidetracked. This is actually cool. This is useful. React Native tools. No. This is an extension, but Okay. Cool. Hmm. This is so before returning, we want to basically copy all of this into one frame. No? By this is width times height, then of y plus then of ud sample plus of ud sample. Yeah. Okay. Uh, yuv to copy. So we want to copy y in this. No. First will be y. Second will be u downsampled. Okay. Hold on. Never mind. Frame then of y plus then of uds, and we will vds v downsample. So we have copied all three. So this final YUV420 frame, frames of I. Wait. So hold on. We are overwriting the existing. I don't like that because that was, I think, that was our input, no? Mm. I'm just going to converted down some. Frames is make uh, by oh we what does it say here? It just writes the entire thing in frames. Why UV frame make yeah, yeah. Frames if I equals one UV frame. Okay. Hmm. 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 So oh okay, so we are doing this for one particular frame of the okay. Okay, I understand it. I understand it. So this all of this is just for one frame. Hmm. And convert RGB to YUV will yeah, wait byte len len of frames. Yeah, not sure how because we could copy it. 0 and then convert frames and copy convert ds frames. Yeah, that I no, it's a matter of principle. Framesify, framesify. Okay. Yeah, our function cannot alter the state of something, now the input. So yeah, we have converted the whole thing. Again, not sure what the size is. We'll put a 2 here, show size, and the right is included file to disk. Control how so why is minmap here? Here split actions. Hmm. Hmm. Yeah, I'm just taking sort of a break and looking at extensions. Yeah, just crazy. I like just going through. Oh, use code icons. How does that look like? No. Mm. I don't have that sidebar. It's all here. To-dos. I don't like this. I want the top, bottom, default. Yeah, nice. I like this now. This nice. Let's install this as well. Dude, this codec on fields. Material icons. How does it look like, dude? That's what I want to know. Captured mode for VS Code. That is nice. Okay, I kind of frequent this. Monochrome later. Dark. Dark is actually really good. Oh yeah. Just icons. Okay. Yeah, let's uninstall this. I don't like. I think I like this one more. It's like more usable. Cool. Yeah, this looks better as well. I think on screen it looks less distracting. May have to zoom in a little more. Mm, this is fine. Yeah, this looks massive on my screen, by the way. Yeah, but anyways, so uh, So we have completed this thing, our encoding of the video. Video encoding is complete. Now what we need to do is to let's look at this thing. We have flattened it into a single slice for each frame. Yeah. Okay, so video encoding is done now. Uh, this constitutes our video encoding. Okay. Oh, you can't make it bold. Okay. Uh, we have the video encoding part. Okay. So codec consists of encoding and decoding both. We just have to reverse it, I think. Encoded. Hmm. Also, they are writing the file into like a YUV format. Okay. What is this 0644? It's like the permissions, no? Like people OS level permissions or something for the file. Um, this is better. This is like my new thing. Okay, great. Oh no. What the hell? This is doing- maybe I have to download. But yeah, VS Code is like yeah, see how to even see anything like useful and make it cover half the screen. Yeah, so and yeah, what the hell? Okay, then GA go. Okay. Okay. Write file encoded.yub bytes.join frame 0644 error not equals nil. Oh. Okay, looks like we have mm, uh, okay. Right. That's fine. Write file to disk. Uh, file. Write in file. Hmm. Okay, so write file to disk. This. If yeah, I think we have done these two things. The only thing left is I don't even know what this process is called. Like we'll simplify the data by computing the delta between each frame and blah blah blah. Hmm. File to disk. String. Um, Just write file. I don't know. Let's write file writes data to the named file, creating it if necessary. Output name, comma. What happened? Yo, what? Hmm. Uh, Name string. We want permissions. So OS dot mode. Is it like this? No. What is this? Huh. So it's FS. File mode. Not home string. And I just get a 0644. No. Mm, we remember it, so why not? Oh, this is what want Something. Oh, okay. So, but then the thing is, can it can it always be this thing? What do you say? Like a double byte, like a like a two-dimensional array. Yeah, is what I mean. Do we want to fix it to that? Whatever, right? अभी क्या इशू है? अरे नहीं, what? This is fine. Should be fine. Have, want. But I don't get it. Not enough arguments in call to call bytes not join. Okay. But then what? What? Oh, okay, okay. So you need to this thing. We need to. What does join even do? Concatenates element of S to create a new byte slice. We just want we just want this to be concatenated into a single, so nil. Okay. If error is equals nil, then no. Equals. Yeah. So let's check for what? I have no idea. Oh shit, what's gonna happen now? Is this is this going to go crazy? The power of G. Hell yeah. I love the power of G. Nope. Now let's see. I want to see. Find VS Code, rip grab. Please install rip grab manually. Sudo s rip grab. It is already installed. Which rip grab. What? Rip grab. Come on, not found. Grab alias to grab color auto. Then not just install it. What the heck, man? Command not found. What is RG? Oh, it's RG. It's RG. User bin RG. VS Code. H23 regret this setting. Damn, why is this finicky? Slash user in yeah, some BS, bro. Yes, let's focus on the task and hand and getting really set right now. Okay. Read frames, convert RGB to YUV. Now we want to uh, let's see. Downsampling is also done. So is copying. So let's add all of this in the main function. Read frames where we get frames, right? Then convert RGB to YUV. Converted frames, or I'd say encoded, and maybe not. Oh, actually, it is encoded. Yeah, encoded frames. So IUV, we want width, height, and frames. Right, height it is. No. Uh, File. So output name. Um, okay, write the file to disk, encoded frames. This is done. Hmm. Let's look. Encoded make okay length frame. Okay, yeah, so encoding is left completely not done. Exactly. Hmm. Var deflated bytes dot buffer. Now we have a delta frame. So okay, first of all, let's correct this. Hmm, okay. Uh, Encoded frames for I in range of frames, computing delta to each frame. What is this called? These are called predicted frames or P frames. Okay. Make frame 0 the keyframe. Okay. Hmm. What is this even called? Like run length encoding. Okay, we have a delta frame. Okay. Oh, so there's size. See, so what have they done? Just okay. Okay, fine. Uh, hmm, no, yeah, actually pretty late. I think we should wrap up soon. Um, let's see. Okay. So we simplify the data by computing delta between each frame. So this is what I don't get. You're just subtracting frames. What? Okay. Also called as p frames. RLE, byte, and This is just the run length encoding. So count and value in this encoded. Right, we're just doing this for the sake of it. It looks like so delta. Okay, so this is the delta. Okay, delta is what? Like literally just subtracting shit. Okay, fine. Uh, okay. So var deflated bytes dot buffer, um, numerator and deflated best compression. Okay, but so you just where is W is this thing. This is the keyframe. So right. So we deflate this one, and then delta G equals. Okay, so we basically abandon the run length encoding. We just compress it here like this using. Mhm. Okay, but so is this the best algorithm that is used? So this is still a part of encoding, right? Where we basically have the delta, and now we are just compressing the delta as well as the original image. Are we storing it in the same place? Like, mm, let's see, delta is here. We've written it w dot write. So is it like that appends it or what? Okay, looks like w dot write does append. Yeah. So we get the deflated one. Okay. So this is the final step. Hmm. Okay, so this was not fully complete. We have a few more steps here, here and here. So uh, calculate key frame and delta from keyframe. Keyframe. Mm, and then this thing compress keyframe delta. Okay, so this is the last step. Okay. So this is sort of the process. Read video, read input video, convert this, downsample, V, compress keyframe and delta. And it's mm. Okay, yeah, I do have a video that yeah, so this video on RGB2, I have this, so you can um, maybe you can paste it here. I think they've given a command as well. Let's wait, yeah, we don't know the dimensions of the video. Properties, permission checksum, no. Okay, this is 51 MB by the way. Uh, no, no, no. No, what do we want? We want yeah, we want this thing for the video. The dimension, अच्छा नहीं dimensions तो ऊपर ही रहेंगे ना. The default ones for this, it's 384 and 216. Okay. Go cat RGB. What is the video RGB? Go. Oh, HD 216 216 WT WT 384. Oh, what? Yeah. Oh my God, this is some alias. Ah, yeah. Whatever. Freaking Franklin. Yeah, we'll do the rescue. We can add video.rgb. do um this thing. Um, 216 384 384. Oh man. Oh, okay. So what like plan? Uh, what? Mm, mm. Is it just the two places? फिर किधर error आ रहा है? Let's see. Oh, oh, you can't. Is not able to read from stdin. Is that the issue? Hey, wait, what? We have an encoded. But, so no, it's empty. Okay. It was just made. No, but then what? How is this called? Is there no error? Acha, there is no error. Hmm. Yeah, yeah, this needs to fail loudly then. If no, yeah, that's true. It'll either be null. No, I will say that is because errors are uh, this thing unexpected EOF. Mm, unexpected. There we are. What is wrong here? What is so wrong that okay, we are in a for frame sentence 3 io dot read full if so err io dot read full os dot scin yeah, frame. Mm, yeah, yeah, this looks fine. What io dot read full frames equals append frames of frame. This still looks fine, man. If error is not equals nil. I'm stupid. Yeah, no, it will should work now. No, it did not. Did it work? It did not work. Let's see. Oh, not equals nil. I have to treat full. Oh, okay. There's nothing. Yeah, right. In the debug cycle, so that's fine. Okay. Index out of range with length. This. Did I enter the height and width wrong? 384 and 216. So width is 384. You know what? Let's just add the width and height correctly here. It is 384 and 216. Hmm. Index out of range. Panic. Main convert 56 and 26. Sure. Okay. Oh, okay, okay. So this was J plus. This should have been J plus equals 3, no? Or J plus equals 2. What? This is conversion वाला part. नहीं. I see the culprit. Same thing. Yep. Hmm. No, what? Okay, hold on. Four. This is all. This looks correct. R. Oh, well, this is good that we did it right now. This is where it's saying we had this thing. Index out of range. 82945 with length 82944. Okay. Okay. Um, So just basically 82945 was the value, and mm, this is correct. R plus 1, R plus 1, C plus 1 plus C. Okay, the thing is, I don't know where to check for this one. Where to check for this one? This is correct. This is exactly how. Because row is the height, width is the column, plus 1. It's happening on 90, so I would assume uh, it's on 90. Hmm. Uh, no, I don't think. Let's check U. Array U, width and height. Width times height. Then should this have started from 1? It doesn't make sense now. Because it's anyways less than. But